So it is clearly stated in the screen. What is the topic?
The unit circle and circular functions.
Okay, so you have, I know you are very familiar with the unit circle, which is I have already discussed to you previously. And then we already come up with the circular functions. We have sine theta, we have cosine theta, tangent theta, and then we have cosecant, we have secant and cotangent, right?
Yes.
Yeah, so you are familiar with that. So for the basic trigonometric function like sine, cosine, and tangent, you use the SOHCAHTOA, right?
Yes.
Yeah, so that just like, for example, we have sine theta, we have there, if the angle is in here, then you are going to have to apply the SOHCAHTOA, which means opposite all over hypotenuse. So our opposite side is AB all over the hypotenuse, which is AC, right? So that is why you have here sine theta equals to AB all over AC, right?
Yes.
Okay, so take a screenshot if you want to have a, I know you have this already in your previous discussion inside the class.
Yes, sir.
Yeah. Okay, so you're done. Are you done taking a screenshot?
Yes.
Okay, so let us move on with our discussion. So kindly read.
Circular functions. A unit circle has its center at the origin and at radius of 1 unit.
Okay, so you have there the circular functions is a unit circle. When we say unit circle, it is a circle consisting of a radius with 1 unit. Correct? So when I say 1 unit, the distance from the origin going to any point on the circle, it's equivalent to 1 unit. Okay? So as you can see, the trigonometric functions of angles theta in radians are found by choosing a point xy, and you know that this is actually how we actually describe the coordinate points. We write them in terms of x and y, right? On the unit circle can be written as the function of the arc length s. Okay?
Yes.
So from this point going to that point, we know that this point represents the arc length of s. Okay? So as you can see, the pink one. Okay? So wherein our x coordinate is our cosine s and our y coordinate is our sine s. Are we clear on that?
Yes.
Okay, so when interpreted this way, they are called circular functions. Okay, do you want to take a screenshot?
Yes, sir. Done. Thank you.
Okay. Now, the circular functions for any real numbers s represented by a directed arc on the unit circle. So when we say sine s, that pertains to our y, we have cosine s that pertains to our x. And our tangent s is equals to y all over our x. So we have a restriction that x must not be equal to 0, because in the event that x is equals to 0, then it will make the whole function undefined, correct?
Yes.
Okay, so you have the cosecant s, we have 1 all over y. We have secant s, we have 1 all over x. And then we have cotangent s is equals to x all over y. So as you notice, from tangent s going to cotangent s, we always set that the denominator should not be equal to 0, because in the event again that our denominator is 0, then the whole trigonometric function will be undefined. Are we clear on that?
Yes.
Okay, you can now take a screenshot.
Done, sir.
Okay, so I know you are familiar with this. Last time we have derived the given values per unit circle, whether it is in the radian measure, correct, Jessalyn?
Yes.
Okay, so can you have a look in your copy? So from 0 here, so when we divide the circle into 4 partitions, we know the first partition is pi all over 2, correct?
Yes.
Can you follow?
Yes, sir.
And then followed by pi, and then we have 3 pi all over 2, and then we go back to this point, which is 2 pi, correct?
Yes.
Now, in the event that we are going to divide our pi into 8 partitions, okay, so the first partition is 2 pi all over 8, which means pi all over 4, correct?
Yes.
And then pi all over 2, right?
Yes.
And then 3 pi all over 4. And then you have
Yes.
pi. And then you have pi all over 4. And then you have 3 pi all over 2. And then we have 7 pi all over 4. And then you go back again to 2 pi. Right? So that is if the partitions is equivalent to 8 partitions. So the second one that I asked you to do is to divide the unit circle into 12 partitions, right?
Yes.
Okay, so when we divide the unit circle into 12 partitions, then we come up that the first partition is equivalent to 2 pi all over 12. And when we simplify that, that becomes pi all over 6, right?
Yes.
And then followed by pi all over 3. And then pi all over 2. And then we have 2 pi all over 3. We have pi all over 6. And then we have pi. We have 7 pi all over 6. And then we have 4 pi all over 3. And then 3 pi all over 2. We have 5 pi all over 3. And then 11 pi all over 6. And then we go back to 2 pi. So these are the basic Jessalyn radian measure in a unit circle. Always remember that. So even without using your calculator, we can actually derive this, the value of the different trigonometric function in the unit circle using the properties, the theorems rather, related to Pythagorean theorem. And the other one is that we are going to apply, because we are going to apply the special right triangle. We have the 45, 45, 90 degrees. We also have the 30, 60, 90 degrees special right triangle, right? Correct?
Yes.
And then, so when we say 45, 45, 90 degrees, we are talking about an isosceles right triangle. So we were able to derive the value of pi all over 4. So when we say cosine pi all over 4, we have square root of 2 all over 2. And we have sine pi all over 4, we have square root of 2 all over 2. Now, if you look at this, when you move to quadrant 2, because this is quadrant 1, right?
Yes.
Yeah. So I know you are familiar with the Cartesian coordinate plane. This was actually taught to you, I think, in grade 8 or grade 7. I'm not really very certain, okay? But I think it will be in grade 7. So you have here, so the counterpart of this, I know the Cartesian plane is divided into 4 regions, okay? So you have the first region, this is the first quadrant. Second quadrant, we have the third quadrant, and we have the fourth quadrant. So every quadrant is unique. So why do I say unique, Jessalyn? Because the values of x and y carries a different sign. Okay? So in quadrant 1, you notice that our x is positive and our y is also positive. Correct?
Yes.
Okay. Now in quadrant 2, you notice that our x here is negative while our y is positive, right? You see, our x is negative 1, we have negative square root of 3 all over 2, negative square root of 2 all over 2, we have negative 1/2. So you notice that our x in quadrant 2 is negative while our y is positive. Correct?
Yes.
Okay. Now, in quadrant 3, we have our x to be negative and our y at the same time is also negative. So that is why you notice you have negative square root of 3 all over 2 and your y is also negative 1/2. Okay? So, lastly, in quadrant 4, our x here, because it belongs to this side, and we know that this side, the value of x is positive and the value of y is negative. Correct? Because it's going down, right? So that is why you notice our x values are positive while our y values are negative. So do you have any question before we proceed?
No questions, sir.
Okay. Now, when we apply the Pythagorean theorem in a unit circle, I have also discussed to you previously that since our radius is 1, correct? So therefore, if we get the Pythagorean theorem, if we apply that, that becomes x squared, meaning to say, from this point going to that point, if we are going to apply the Pythagorean theorem, that is x squared plus y squared equals to 1 squared. But we know that when we square 1, that means that gives us 1. So that leads us to a general equation that is equal to x squared plus y squared equals to 1. That is it at the bottom. Can you see it?
Yes.
Okay, take a screenshot.
Done, sir.
Okay, do you have any question with regards to the derivation? Because we have already derived the values of our pi all over 6 last time, right? Using the 30, 60, 90 degrees, correct? Special right triangle. Right, Jessalyn?
Yes.
Okay. So, now, kindly read.
Um, evaluating a circular function. Circular function values of real numbers are obtained in the same manner as trigonometric function values of angles measured in radians. This applies both methods of finding exact values, such as reference angle analysis, and to calculator approximations. Calculators must be in radiant mode when finding circular function values.
Okay, so it is clearly stated in the concept notes that you have made mention a while back that circular function values of real numbers are obtained in the same manner as trigonometric function values of angles measured in radians. Because last time when we actually measured the radian, the unit circle using the radian measure, we have pi all over 2, okay, and so on, right? So we have also what we call the exact values of that using the reference angle analysis, because we have to look into what kind of angle is that. So from our initial side going to any point on the circle counterclockwise, when I say counterclockwise, I'm referring to the movement from 0 going up to the pi all over 2, and that is what we mean by anti-clockwise, right? Or counterclockwise, right, Jessalyn?
Yes.
And because in IGCSE you are allowed to use your calculator, that is why you can also use or apply the calculator approximations. Now, but always remember that your calculators must be set in radian mode whenever you find the circular function values. Okay, so is your calculator in radian mode?
I don't know how to do that, sir.
You go to mode and then search for radian.
There's only classic expression and RPM.
Wait, you have there when you click mode, you have comp 1 and then SD we have 2, we have regular, right?
My calculator is different, sir.
Oh, so when you click, what does it displays there?
Classic, expression, and RPN.
Oh, I'm not really familiar with. I think your calculator is a higher version already. That is a graphic or calculator, right? I think you're using a graphic calculator.
It's a hyper
Hmm.
scientific.
Scientific, yeah.
It's a hyper scientific.
Yeah, so I think you are using because I'm just using a normal calculator. So whenever I press the mode, so the first thing that will be displayed will be comp and then SD and then regular, and then when I press another strike, then it leads me to degrees, radian, and GRA, correct? So I will just press 2 for the radian measure, but I think you have to search it in Google. With that, you just specify whatever calculator you are using and then how to change it in radian measure, right, Jessalyn? So I know
Yes.
you know the unit of your calculator, right? So you go to Google and then search it later on. Okay, so let us proceed. Now, finding exact circular function values. So find the exact value of sine pi all over 3, sine pi 3 pi all over 2, cosine 3 pi all over 2, and then tangent 3 pi all over 2. So locate in the unit circle that you actually take screenshot a while back, where is sine 3 pi all over 2, and then what is the value?
$270.
Okay, so evaluating a circular function at the real number, 3 pi is 3 pi all over 2 is equivalent to evaluating it at 3 pi all over 2 radians, right? Correct? Jessalyn?
Yes.
Okay.
Yes.
So an angle of 3 pi all over 2 intersects the circle at the point 0, -1. Am I right?
Yes.
Correct? So since sine S is equals to Y, cosine S is equals to X, therefore tangent S is equals to Y all over X. Correct? This is the one that I have actually explained a while back. Correct, Jessalyn? Okay.
Yes, sir.
Next. So when we say sine 3 pi all over 2, that means that is the value of our y, and that is -1. Can you follow?
Yes.
Okay. Now, our x, which is cosine 3 pi all over 2, which is 0. Correct?
Yes.
And then, so tangent 3 pi all over 2 is undefined. Why undefined? Because -1 divided by 0, as we say, that our x must not be equal to 0, because in the event that x is equals to 0, it will make our trigonometric function undefined. Right?
Yes.
Okay, so try to use your calculator. You divide -1 divided by 0, that's error. Correct?
Yes.
Okay, that is why in math we don't say it as math error, but we say it is as undefined. Okay, are we clear?
Yes, sir.
Okay, next. Finding exact circular function values. Use the figure to find the exact values of cosine pi all over 4 and sine pi all over 4. So, you can see the one that I have actually presented a while back, the unit circle. Okay, so where is 7 pi all over 4, Jessalyn? It is coming from 0 going anti-clockwise until here, correct? Can you see the pointer of my mouse? 7 pi over 4 is somewhere here at this point, correct?
Yes.
Okay.
In between 3:15 and 3:30.
Okay, correct. So you notice that the values of our x is square root of 2 all over 2, and the value of our y is negative square root of 2 all over 2, right?
Yes.
Okay. Now, the real number, 7 pi all over 4, corresponds to the unit circle point square root of 2 all over 2 and negative square root of 2 all over 2. So therefore, we can say that cosine 7 pi all over 4 is equals to square root of 2 all over 2, and sine 7 pi all over 4 is negative square root of 2 all over 2. Okay, now, if you are going to use as what I have made mention, this is in terms of reference angle analysis. So if you use the calculator approximation, then you can use in radian measure. Can you actually, Jessalyn, what is square root of 2 all over 2? Divided by 2.
Zero 0.707106781.
Okay, wait. So if I'm using now my calculator that is in radian measure, I will just enter cosine and then press 7 and then shift pi and then all over 4 and then press, what is that again? 0.7071, right?
Yes.
And then 0.6781, correct?
Yes.
Okay, so meaning to say, just as last time, we actually had a problem because our calculator was not set in radian measure, right? Radian mode. That is why we have we have to calculate first the other way around, correct? And then we have to tally. So but if our calculator is set in radian measure or radian mode, then we can already get the calculator approximation that is actually fitted for cosine 7 pi all over 4 without dividing square root of 2 all over 2. Do you understand? Can you try, Jessalyn, if your calculator will display 0.7? Try first.
Yeah.
If you input cosine 7 pi all over 4, what does it displays in your calculator after pressing equals?
Let me check. 0.99539.
So it's different, right? It's different, correct?
Yes.
Yeah, because it's not set in radian measure. Can you set it in radian measure? I will give you time to go to Google using your calculator. Just enter how you will change the mode, because I am not familiar with your calculator, Jessalyn, and then tell me if you're done. Okay?
Okay, sir. Sir, are you using Casio right now?
Yes.
Okay.
The very basic. Jessalyn, can you try pressing like this? Cosine and then open and close parenthesis 7 pi and then enter the value and then close parenthesis. Let's see if it will give you 0.70771 using your calculator.
No, sir. It still gives 0.999.
Oh, it's still, yeah. So that is why we have to change that into radian mode.
Sir, I downloaded the Casio calculator, and for mode I got complex, stat
Yeah.
slash tr, base n, table, matrix, vector, and that's it.
Come again. What does it says there?
Complex, stat slash distur, base n, table, matrix, and vector.
No, you go to, I think it's the first one. Click the first one. And then what does it says there when you click the first one?
It says complex.
Yeah, complex. And then after that you click, you press that, and then what does it appears next?
It's still 0.999.
Oh, so I think I have to familiarize with your calculator now. So, but anyway, you go to Google.
Yeah. Yes.
So you go to Google and then enter cosine 7 pi all over 4 if it will give you 0.70710671. Or just type what is the value of cosine 7 pi all over 4. So it will give you square root of 2 all over 2, and the other one, it will give you a value of the decimal point.
It says 0.707.
Yes, that's correct. Yeah, so meaning to say, Jessalyn, since we are having a different what is this calculator, so my advice is that you explore your calculator, you try to search how you will change the mode. Okay, correct, Jessalyn? And then you enter first the one just like the basic, just like this one, sine 7 pi all over 4, and try to see if the answer will match to the answer that I have given. And when it matches, therefore, meaning to say, you can use that already in getting the circular function values of the different trigonometric functions. Okay? Are we clear?
Yes.
Okay. So take a screenshot.
Okay.
Okay, now. Okay, so if I will ask you, Jessalyn, what is the circular function value of, for example, negative 4 pi all over 3? Negative 4 pi all over 3. So what is the cosine of negative 4 pi all over 3? No, without using your calculator, Jessalyn.
Oh.
Without using your calculator. Okay, so I'll teach you how. So always remember, Jessalyn, why I am presenting these things to you. Why did we derive the values? You memorize it, put it in your head. Okay? Because it will facilitate you to calculate faster if you know the radian measure and its equivalent. Always, Jessalyn, can you follow? Do you understand what I mean? So just like, for example, the one that I have taught you, so when we say 4 pi all over 3, you are moving from this point going to that point, right? That is going here, right?
Yes.
Now, but since my question is, what is the value of cosine negative 4 pi all over 3? So meaning to say, from this point, you are going to move clockwise, going this way. So the opposite of this is this one, right?
Yes.
Okay, so meaning to say, your 4 pi all over 3 negative will be here. Instead of 2 pi all over 3, they will interchange because the movement is from here going that way. Correct? Do you understand?
Yes.
So when I say, what is the value of cosine negative 4 pi all over 3, right? And that gives us negative 1/2, correct? Or 0.5, correct? This is negative 1/2. Do you understand?
Yes.
Okay, so if I will ask you what is the value of sine negative 4 pi all over 3, then without calculating it using your calculator, you will give me square root of 3 all over 2. So that is how easy it is when you memorize everything there. Okay, so again, can you explain to me? If I will ask you what is the value of sine negative 5 pi all over 3. What will be the value of sine negative 5 pi all over 3?
1/2.
Wrong. Sine is y. That is square root of 3 all over 2.
Oh,
You still-
sine is y and cos is x.
Yes, cosine is x. So you did not get it because you just look at the values here. This is positive. Pi pi all over 3. Where is the counterpart? Here, right? Pi all over 3. Correct? Because if you will move this going that way, meaning to say, pi pi all over 3 will be here. Negative. Correct? Jessalyn?
Yes.
And negative sine negative 5 pi all over 3 will be square root of 3 all over 2. Were you able to follow?
Yes.
Okay, so again, I think you did not get that concept right. Okay, so I'll just do it like this. Okay, so kindly give me the value of the circular function, which is negative cosine negative 7 pi all over 6. Negative cosine negative 7 pi all over 6. Where is the counterpart? First, you have to locate where is 7 pi all over 6, and then look at the opposite of that, and then take the x value.
Is it negative 3 pi? Wait, no, sorry. Negative 3 squared.
3 square or negative 3 all over 2?
What's 3 squared?
No. Where is 7 pi all over 6? This one, right?
Yes.
Okay. So, meaning to say, if it is negative, then it is from here going this way. That is pi pi all over 6. Correct?
Yes.
So, negative 7 pi all over 6 cosine, that is negative square root of 3 all over 2.
I said that, sir. I said that.
You say squared.
No, I said negative square root of 3 over 2.
Yeah, that's correct. Okay, how about the value of sine negative pi all over 4? Sine negative pi all over 4.
Negative Square root of 2 over 2.
Perfect. So see, you're able to locate, right? So again, the greatest advice that I will give you, Jessalyn, familiarize yourself with the different partitions. So if I will ask you, okay, what is 11 pi all over 6 in degrees? So you will give me 330 degrees, right? Correct?
Yes.
So what is the value of cosine 11 pi all over 6? So you will give me square root of 3 all over 2, right? Because you are already familiar with the unit circle. So again, the negative will only, the point of reference is that you will move from 0 clockwise. Okay? Jessalyn? If it is positive, anti-clockwise. So from 0 going up, we have pi all over 2 going to 2 pi. That is positive. Are we clear?
Yes.
Okay. Next. Kindly read.
Finding exact circular function values. Use the figure and the definition of tangent to find the exact value of tan negative 5 pi over 3.
Okay, so again, moving around the unit circle 5 pi all over 3 units in the negative direction because it is negative 5 pi all over 3, right? In a negative direction yields the same ending point as moving around the circle. Okay, so see, if you get tangent negative 5 pi all over 3, locate where is negative 5 pi all over 3. Jessalyn, where is that? Because that is from here going, this is 5 pi all over 3, right?
Yes.
The
60
opposite
degrees
of this is pi all over 3. Correct?
Yes.
So meaning to say, if it is negative, so from this point going that way, and you will end with pi all over 3. That is what is stated in the concept notes that I am presenting to you. Moving around the unit circle 5 pi all over 3 units in the negative direction yields the same ending point as moving around the circle pi all over 3 units in the positive direction. Correct? Do you understand? Okay. So meaning to say, it is just like saying that tangent negative 5 pi all over 3 are the values 1 of pi all over 3, and that is 1/2 and square root of 3 all over 2. Am I right?
Yes.
Yes. Now, so since that is tangent, we know that tangent is applying SOHCAHTOA. It means that negative 5 pi all over 3 corresponds to 1/2 and square root of 3 all over 2. Now, we know that tangent theta is equals to y all over x. So, which means to say that y is our sine theta. Correct? Correct, Jessalyn?
Yes, sir.
So, what is our sine theta?
Our sine is square root of 3 over 2.
Okay, so all over, what is our cosine theta? Because that is x, right?
1/2.
Okay, 1/2. Now, so that is why you have there tangent of negative 5 pi all over 3 is equals to tangent pi all over 3, or that means to say square root of 3 all over 2 divided by 1/2. So when we divide that, I know I'll use the pen here, this one, right? So I'll write it down here. So square root of 3 all over 2, erase, okay, all over 2, correct, Jessalyn?
Yes.
Divided by 1/2, so we get the reciprocal of that, that is 2 all over 1, correct? And then we change the operation to multiplication. Correct? Can you follow?
Yes.
So we cancel what is common. What is left is square root of 3 all over 1. And what is square root of 3 divided by 1, Jessalyn?
Square root of 3.
Okay, so that is square root of 3. That is why the answer is square root of 3. Oh my God.
Eight.
Okay, so are we clear?
Yes, sir. Yes, sir.
Okay. I'll just write it down first. So square root of 3 all over 1, it means to say that is equivalent to square root of 3. So that is why you notice you have this here. My stylus pen becomes very sensitive now. Okay, so do you have any question, Jessalyn, before we proceed?
No, sir.
Okay, none so far. So is my presentation clear enough for you?
Yes.
Okay. Okay, so next. Okay, so kindly read.
Finding exact circular function values. Use reference angles and degree/radian or your unit circle conversion to find the exact value of cos 2 pi over 3.
Okay, so finding exact circular function values, use reference angle and degree or degree radian or your unit circle conversion to find the exact value of cosine 2 pi all over 3.
Negative 1/2.
Okay, so caution, always remember, Jessalyn, that a common error in trigonometry is using a calculator in a degree mode. So when radian mode should be used, remember, if you are finding a circular function value of a real number, the calculator must be in radian mode. That is why when you enter your the data in your calculator, it will give you a different answer because the mode should be changed in radian. Okay?
Yes.
So when you take the IGCSE, since you are allowed to use your calculator, do not forget to always change the mode in radian measure. Okay?
Yes, sir.
Okay. Okay, now approximating circular function values, find a calculator approximation for each circular function. So what is the value of cotangent 1.3209 using your calculator?
Cotangent. How do you write that, sir? In calculator.
Yeah, in your calculator, because you don't have your calculator there with cotangent, right?
Yes.
Okay, so in my previous what is this discussion, you know that cotangent, so since tangent is sine all over cosine, cotangent is the inverse, the reverse. So tangent is sine all over cosine, right, Jessalyn?
Yes. Yes.
So cotangent, it means cosine all over sine. Correct?
Yes.
So meaning to say, you will write cosine 1.3209 all over sine 1.3209.
Oh, okay.
I have displayed that last time, right? From the beginning. here. Correct? See, cotangent S, tangent is y all over x, cotangent is x all over y. Can you follow?
Yes, sir.
Hmm.
So it's 43.3686.
So again, what is the... So, meaning to say, what is your answer? Approximately
43.368.
So that, because that is not in radian measure. So meaning to say, that is the reciprocal of 1 all over tangent of 1.3209. So if you go to Google, because your calculator is not in radian measure, that is why you will obtain a different answer.
Oh, okay.
So your answer should be 0.2552314915. So if we are going to write down in 4 decimal places, then you will have 0.2552. You go to Google first because you have to explore your calculator.
0.255231.
Yes, correct. Okay, so now using again Google, find the value of secant negative 2.9234. What is secant? That is secant. I ask you to take as
1 over
1.
x.
So 1 all over x. So meaning to say 1 all over cosine. So you will actually enter there 1 divided by cosine of negative 2.9234. And that gives you the answer.
Negative 1.024.
Correct. Negative 1.0243. Okay, so very good, Jessalyn. Okay. So do you have any question?
No.
So we are almost ending because it's almost one hour already. So I think you told me that we are going to have lesson until 12 only, right, Jessalyn?
Yes.
Okay, so maybe sets will come next meeting. Okay? So
When
have
is
a
our
great...
next meeting, sir?
Come again?
When is our next meeting?
Yeah, it's up to you. You told me it's Tuesday, Thursday, right?
But you said that next Tuesday that you have an operation.
Yeah, I have a vaccination. So I think I'll
Oh.
just message you if I feel better, then I will, because I will have my vaccination in the morning. So if I did not experience any side effect, then I can teach you in the afternoon at 3. Okay?
Okay, sir.
Okay. Have a great day, Jessalyn. Bye.
Bye, sir. Thank you, sir. Have a nice day.
Yeah, you're welcome.